welcome to this session again. So in this session we'll learn bond characteristics or bond parameters. So covalent bonds are determined by, it is characterized by 4 parameters mainly. These parameters are bond length, bond energy, or another name is bond strength, bond angle, or bond order. So what is bond length? So bond length is already we have seen earlier also. Let us see once again. It is defined as the average distance between the centers of the nuclei of the two bonded atoms in a molecule. And normally we take the unit as the angstrom, picometer, nanometer. So these are the normal general unit of the bond length. So this bond length is practically it is found by, it is measured by X-ray diffraction. This is one technique to find this bond length, or you can say electron diffraction techniques. So bond length of Ra and Rb, which are, this is nothing but the covalent area. You can see this is the two different atoms A and B, covalent molecule. This covalent bond is there. So this is the total bond length. This is the Ra is the radius of A molecule and Rb is the radius of the B molecule. Now this bond length is affected by some of the factors like resonance, electronegativity, hybridization, or steric effects factors. We will see this how this is affected by taking some examples. Let us take one example. Bond length is proportional to size of the atom. How size of the atoms is increasing or decreasing, how bond length is being affected. So let us take for hydrogen. Hydrogen combining with the hydrogen, 74 picometer. So if it is atoms is larger in size, carbon, so picometer again increased. For chlorine, again carbon is combined with the chlorine, so you can see the chlorine is again larger than the carbon, so bond length is again increased. So 170 picometer as compared to CH. So here you can see in the comparison within halogen HF92, and size of the chlorine, bromine is increasing, the bond length is increasing. So carbon Cl are bigger in size over here, so definitely bond length increased. Next, bond length is affected by the multiplicity of the bonds. So like a triple bond has less bond length, followed by the CC double bond and single bond. This is the resonating structure of carbon-carbon, so partial double bond. So this will be more greater than the your single covalent bond, or in between the double and the single covalent bond. So this is due to the resonating structures of the carbon-carbon. 140 picometer. So first one, this one, second, then after this one, third, this one, fourth. So this is decreasing order. Bond length is again affected by the type of hybridization. So greater the S characters, concentration etc. will decrease, then bond length of the S orbital is smaller in size. For example, suppose this SP. So SP have 50% S character, so bond length will be your smallest, 107 picometer. If S character is decreasing, percentage S decreasing, so bond length will increase. So SP2 have more bond length, 33.3%. So you can see the CH is how much? 110.3 picometer. While in SP3 it is 25%, again it is decreased, so bond length is again increased. So these are the factors which are affecting the bond length. So here you can see the bond length of this one. This is the first period, so this is the bond. HH bond, this is the first period, second period. So you can see there's a 74, 109, these are all in picometer. So this is HN, HO, you can see HF, HCl. This is the first row of element with hydrogen with the first row of element. In second row you can see second row. So carbon nitrogen, you can see this one, carbon oxygen, carbon fluorine, all these structures. So from here you can easily determine the structures. All you can carefully see the second row of element, how this bond length is changing. So by comparing you can easily understand. For larger element, silicon again larger, so you can see how bond length is increasing. So it will be helpful to understanding the concept. Even if you see the multiple bonds, you can see carbon-carbon bonds, CO-PO bonds, carbon-carbon triple bond, nitrogen, sulfur, oxygen. So this is the multiple bonds, you can see the bond length. So now let us see the bond type. So this is the bond type, bond length and triple compound. So if the carbon-carbon is there, so it is sp3, bond length is 1 picometer, 54 picometer. So this is the compound. sp3, sp2, it is this much. So this is sp3, this is sp2, sp2. So these two are sp2 and sp2. sp3 sp, so this is the sp3 sp sp, this is the sp3, and this will be your sp and sp. sp2 sp2, so sp2 occur between the two double bond. sp sp, so it carbon, this is two carbon, you can see the bond length, carbon carbon double bond, sp2 sp2, so this is sp2 sp2, sp2 sp 131 picometer, so this is the sp2 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 sp. So this is your sp, this will be your sp, but this will be your sp2 and this will be your sp2. sp sp is all are sp 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 sp, these three carbon I am talking, this will be sp because there are two sigma bonds. Similarly for C triple bond, sp sp, this C triple bond, ch sp3 sp2 sp, so this is the sp3 sp2 and sp, and again bond length is decreasing. So now this picture will fully makes you understand about the bond length. Now second factor is parameter is bond energy or bond strength. So it is the amount of energy that is required to break a bond in a molecule. It measures the strength of bond. So bond length is inversely proportional to bond energy. In polyatomic molecules, the measurement of bond strength is complicated. For example, dissociation of water molecules. In water, we write the structure like a HOH. So first one bond is broken. Suppose this is broken. If you break this bond, we will get H in gaseous form and OH in gaseous form. So bond energy is 502 kJ per mole. Again, if you break this bond between oxygen and oxygen separate, hydrogen separate, again you will get this much energy. So average bond energy of water molecules is adding of these two bonds, you will get this much answer. Similarly, you can find the bond energy of carbon and hydrogen. So first one hydrogen is cleaved, it is broken, this much energy is kilojoule released. If second broken, this much, if third broken, this much, and fourth broken, this much. So take the average of these four bonds. So you will get the average of these four bond is delta is this much, and take the average 1663 by 4, so you will get this much kilojoule per mole. So this is the average bond energy of the carbon and hydrogen. Now we will see the important features. So important features of the bond length is the magnitude of the bond energy on the type of bonding is most of the covalent bonds have this much value, 50 to 100 kilojoule per mole, that is 200 kilojoule per mole, and strength of the sigma bond is more than that of pi bond. Second point, you can note it down, the double bond in diatomic molecule, they have a higher bond energy than the single bond, and a triple bond has a higher bond energy than a double bond and between the same atoms. You can see. Third point, magnitude of the bond energy depend upon the size of the atoms forming the bond, that is bond length, and shorter the length, higher the bond energy. Resonance in the molecule affect the bond energy. So resonance is also affecting bond energy. It decreases with increase in the number of lone pairs in the bonded atoms. Why? Because of electrostatic repulsion of lone pair of electrons and the two bonded atom is there. That's why bond energy is decreased down. Homolytic and heterolytic fission. These are two different type of fissions between different type of molecules. They have different amount of energies. So generally the value for the are low for the homolytic fission in the bond as compared to the heterolytic fission. Bond energy decreases from down the group in case of similar molecules. Again note it down. And bond energies increases in the following order, like this is order. So S is less, then P is more, and then Sp more, then Sp2 and Sp3. So we can see this here, carbon carbon 346 no lone pair, nitrogen nitrogen 163 one lone pair, and oxygen oxygen 146.4 kilojoule per mole 2 lone pair. So bond energy is again increasing if the lone pair is absent. Now you can see some data of different bonds and their energies. So this is the hydrogen, you can see this bond, so how it is decreasing. So this is carbon, how the size is increasing, so how this affecting the bond. For double bond, you can see here carbon carbon similar, it is 600%, but if there is more electronegativity in oxygen carbon, so again it is increased, like this oxygen oxygen, nitrogen nitrogen, so double bond, again this more electronegative, so bond energy is increased. Oxygen more electronegative, triple bond is more, three bonds are there, more energy is there. Again you can see oxygen, the size of the atoms is increases, so bond energy also increases. So by you can compare it and you will understand. So I have one more is there. It is this is equal, but it will be more helpful in comparing. So you can see, you can compare between these three carbon, this 3 nitrogen, and this phosphorus, 2 oxygen, 2 sulfur, fluorine, CrCl, Br, II. So you can see in case of fluorine 159, in case of CrCl bond energy becomes higher, and again it is decreasing. So why this is higher? Because there is a more electron density is present in this 2 chlorine, so it is very difficult to break this bond energy of chlorine. So it has higher energy than that of fluorine, and then it is in increasing order than decreasing. So 242 again decreasing, and iodine it is more bigger in size, again it is decreased down. So this is one exceptional case. The electron density of fluorine is less than that of fluorine, so it is very difficult to break down. This is group 17, so just note it down. So this is the trends in bond length and bond energy. So we can compare bond length and energy both together. Carbon carbon, carbon hydrogen, carbon carbon, triple bond, second double bond, triple bond. Similarly for CN, double bond and triple bond. Similarly for CO and CO. So how you can see the trends, how length is decreasing when these type of, and how bond energy is increasing. So this is inversely proportional. So bond length is inversely proportional to bond energy. You can easily predict. Now we will see the next parameter, that is the bond angle. So it is the angle between the two adjacent bonds at an atom in a molecule and made up of 3 or more atoms. It depends factors like a hybridization state of central atoms, lone pair of repulsions. So hybridization state of central atom like sp3, sp2, sp. So you can see the bond angle is again, it is increasing when the percentage S character is increasing. So percentage of S character is directly proportional to bond angle. Similarly, lone pair repulsions, it also affects. In case of water molecule, you can see here. So bond angle is 105 for 2 lone pairs. If it is 1 lone pair, bond angle again increased, because 2 lone pair is again displacing the bond pair to closer to each other. In this case, it is more displacing. So 1 lone pair has less tendency and 2 lone pair more tendency. So bond angle is also affected by the lone pair repulsions. And the third is your electronegativity, which is affecting the bond angle. So bond angle, here we have 2 cases. If bond angle decreases, this case 1, if electronegative central atom is decreases. So you can see this NH3 PHC, so hydrogen is same, but the size of the central atom is increasing. So bond angle is also decreasing order. Similarly, you can see along the period. So H2O, NH3, so oxygen, nitrogen, carbon, boron, beryllium. It is we are going to right to left hand side of the periodic table. So bond angle is also increasing. So beryllium having the largest bond angle, while the oxygen having the with the hydride of oxygen having the lowest bond angle. You can see here. So we are going a period from group 17 to group. This is the 2. So it is decreasing order from the right hand side of the period table to left hand side. So we will get this bond. In case of one central atom is same, and the bond angle increases with decrease in electronegativity of surrounding atom. Like you can see. So central atom is same, but the size of the F3, Cl3, Br3 is increasing. So bond angle will also increasing, because the electronegativity of the central atom is surrounding atom is decreasing. That's why bond angle is increasing. Now we see next parameter, that is called bond order. So it is the number of bonds in a number of shared electron pair between the 2 atoms in a molecule. Like hydrogen. So with these shared atoms, shared electrons is 2. So bond order will be 2. For oxygen, there will be 2 shared electrons. So bond order will be 2. For nitrogen, there are 3 shared electrons between the 2 atoms. So it will be 3. Similarly for carbon 3, it is bond order 3. Even if you take isoelectronic molecules or ions, they have the same bond order. Just mind you, if the molecule having isoelectron, their number of electrons are same. For example, fluorine oxygen, there are 18 electrons, so bond order is 1. For this one, there are 14 electrons, so bond electron will be 3. So bond order is nothing but the directly proportional to bond energy and inversely proportional to bond length. Let me show some table to make it more clear. So this is the bond order, and the number of shared electrons in a bond affecting the length and energy. You can see this is the different type of bond types. This is the bond order 1 2, and this is 1, this is 2, 3 bond pairs, so 3 1, and according to the bond length is given here and bond energy is given here. So you can see, you can easily compare. Let us take carbon. So carbon is again bond length is decreasing but bond energy is increasing. Similarly for the CN, bond order is increasing, bond length is again you can see decreasing but bond energy is again increasing. So bond order is inversely proportional to directly proportional to bond length but inversely proportional to bond energies. So this is a table of average bond energy and bond length. You can compare. This is the all hydrogen, this is the energy, this is the bond length. Similarly for this one, energy length, bond is there, energy length, this is bond of this sulfur, fluorine, chlorine, and energy length. So you can easily see this one and compare it. Even you can see for the multiple bonds also. So for multiple bonds you can see this one, so carbon double bond CN CN. So this whole table will give you and particular areas about the how bond length and bond energy is related to each other.